嗨，各位线上的观众，欢迎回到现场哦。那我相信虚拟化的技术对于所有人来说都不陌生，无论是开发者，或者是技术主管，或者是企业主，对于这个虚拟化的技术相关的推进其实都不是太新的话题。那可是呢，事实上这10年来，虚拟化的技术有长足的进步，让我们现在透过不管是智慧手机啦，或者平板，甚至所有的这个浏览器上面，都可以随意的使用这些云端的相关的工具哦。那其中呢，有一个虚拟化技术叫做 Kubernetes， 事实上是一个非常吸引人、动作也非常快、持续在更新的产品，吸引了非常多开发者的使用跟关注哦。那我们今天接下来紧接着就是Kubernetes 的这一个发明者，也就是他的 co-founder 是 Brendan Barnes 来也是同时现在是微软的 CVP 来为我们分享这个 Kubernetes 最新的进展。那Brendan Barnes 其实是这个一直都在研究这虚拟化相关的技术。他在14年的时候在 Google 第一次共同发表了 Kubernetes 这一门技术，并且在16年的时候来到微软，他现在在推广这个相关的技术，直接可以原生化的透过微软的Azure 去这个云端去执行哦。那紧接着我们就很快的来听听他怎么去分享这个 Kubernetes 跟这个 Azure 相关的这个原生的连结经验跟现在最新的进展。我们进影片。
Hi, I'm Brendan Burns, Kubernetes co-founder and corporate vice president at Microsoft Azure. I'm going to talk to you today about the intersection of the Kubernetes open source project and Azure Compute. Here's a brief agenda for the talk. First, we're going to go over Kubernetes. I know probably everyone has heard of Kubernetes, but some of you may not have had an experience to dive into it in any detail. I'll give you a little bit of an overview of what it's about. Talk about how we take that Kubernetes project and turn it into a service on Microsoft Azure. How we think about open source community and how Azure gives back to the Kubernetes open source community. And then finally conclude with a discussion of Kubernetes in China. So here's a quick overview. I think it's first important to set the context of containers in the history of computing. And I think that oftentimes people think of containers as being a relatively new phenomenon because they're something that they may have only heard of 3, 4, 5 years ago. But the truth is that containers have been around for quite a long time, stretching back to the initial implementation of chroot in BSD Unix in the 1970s. More recently, in the late 1990s, people introduced things like jails, which were oriented around securing processes in the early days of the internet, securing different web servers running on the same machine. Then in Solaris and Linux in the 2000s, zones and C groups were added. C groups in Linux are interesting because they were all about adding resource isolation, not necessarily adding security. But these concepts were all sort of deeply baked into the operating system and not something that most people were thinking about until the introduction of Docker and eventually Kubernetes in the recent years. So I think, but it's really important, I think, to realize that this idea of taking a process and isolating it, either for security or for resources or both, is really not a new idea. We've been working on it for a long time. I think what's new is the ways in which containers have come to change the way that we develop and deploy applications. So when we look at what a container does for a developer, one of the primary things that's of value in the developer ecosystem is this idea of separating out the various dependencies for the different images from the underlying kernel. Previously on a virtual machine, you might have binaries installed, you might have libraries shared between two applications. It leads to a lot of dependencies and tricky management of that software. Likewise, there's deep dependencies between the applications that are running and the kernel that's down below. And that's problematic as well because it means it's very difficult to upgrade the operating system or the kernel to pick up security patches without breaking an application. So it's really a dependency between the applications that people want to deploy, either with each other or with the operating system underneath it. And containers have allowed us to break that up by taking the binaries and libraries and packaging them into a sort of hermetically sealed environment, which allows different applications to run on the same machine without interfering with each other. I think also one of the really important things about containers is that it allowed people to easily take an application that was running and working on their development laptop and push it to the cloud and know that it would work the same way. right? So a container running on your laptop is pretty much guaranteed to run exactly the same way when it comes to the cloud. That makes deploying that application significantly more reliable and eliminates a whole host of problems that had plagued people who were developing in one version of an operating system and perhaps deploying into another. But the container itself isn't the only thing that helps make things possible for developers. Really, most modern applications, if you're for either reliability or scale, are distributed systems that are built up of many different pieces. And so that's where Kubernetes comes in. Kubernetes builds on top of these sort of developer-focused features in containers to provide an API that's oriented around building services, around building things that have replication, that have multiple different things communicating with each other. In Kubernetes, the fundamental concepts are the service, which is effectively a load balancer for directing traffic to a variety of different groups of containers, and the pod, which is a group of containers that are co-scheduled onto the same machine, operating together in a symbiotic fashion to deliver sort of one piece of an application, right? So a service is there to provide a generic interface to a collection of pods that implement the application. But of course, it's not just about running containers and having traffic get load balanced to them. Another really important part of building any application is understanding how do I go from version 1 to version 2 of my application, and that's where deployment comes in. So the deployment is sort of the third important concept within Kubernetes, and a deployment basically is responsible for keeping track of not just a collection of pods, but actually moving those pods from a version 1 to a version 2, and doing that rollout while paying attention to the health of the application, seeing if there's a crash, moving slowly from one version to the next to ensure that you can do a rollout without any downtime that your users might see. Another way of looking at the Kubernetes API server, though, is that it's an abstraction layer on top of infrastructure. So while those developer-oriented concepts are great for building and describing an application that you're deploying out into the cloud or on-premise, the Kubernetes API server also allows you to have a more generic and more unified view of your infrastructure, whether it's running in Azure, an on-premise data center, some other public cloud. If you build applications against the Kubernetes API, you're building applications that are inherently more portable, and you're building using tools that can describe and deploy your application into all of these environments at the same time, despite differences in the underlying hardware. Of course, the more you use data services and other kinds of pieces that are cloud specific, you're going to run into challenges in portability. And so I really think of the portability promises of Kubernetes not as being a perfect, absolutely you can lift and shift an application in a day, but rather that the people and the processes that you're developing for deploying and managing your applications, those skills are transferable, whether they're deploying that application on-premise, at the edge, or up into the cloud. I think the other piece of Kubernetes is that it is really oriented around enabling DevOps, right? And I think we've all had this experience that a two-pizza team is a sort of famous phrase that you should always build teams that could be, fed by two pizzas. It's a real focus on keeping the size of teams in sort of the 6 to 8 person range. And the reason for this is obvious. It's because above 6 or 8 people, the amount of communication overhead that you have for keeping the team in sync, for understanding what everyone's doing, becomes really kind of expensive. And so if you can focus on having smaller teams, you can build more efficient processes. The challenge of this, of course, is that it requires that you have decoupled services. For any real large application, you're going to need to have hundreds or thousands of developers working together. If you really want to have a collection of these two pizza teams, you're going to need to have a way of having a lot of people work together while still staying relatively separate. And Kubernetes really helps makes this decoupling easier. And the reason for this is because all of those services, right? All of those services, they can really provide the gateway to describing a thing that each team can own. So every single service, and this is why sort of microservices has become this popular key phrase, every single team can have 1 or 2 or 3 services that they deliver into Kubernetes. Maybe a team is delivering the edge, maybe a team is delivering the middleware service, maybe a team is delivering a backend. And because they've been abstracted away from each other, and because they're each deploying these containers that can land on the same machine but not interfere with each other, you stand a real chance of being able to simultaneously have large teams working on a big, large-scale application while still keeping the actual team sizes down to that ideal 2-pizza team. I think the thing about these services in Kubernetes is that they provide, again, this abstraction layer. And if there's any theme for Kubernetes in general, it's the idea that abstraction is a really powerful tool. And I guess that's true for computer science in general. Abstraction has always been our tool to isolate ourselves from complexity and enable us to be able to move applications forward. When people think about a service, they don't actually have to think about what's behind that service. And so that means that consumers of your service don't have to worry about if you're scaling or auto-scaling, if you're doing version upgrades, if you have failures in your application. The service abstraction has hidden all those concepts from them so that they can just focus on talking to the APIs that your service is providing. I think the most important thing about this is it doesn't just decouple the design of your system, it actually decouples the operations of your system as well. And so we can actually think of separating out the operations of an application into separate people and separate teams who manage hardware, and it's uniform hardware. It's all the same no matter what application is running on it. An operating system operations team, and it is the operating system with Kubernetes can be made exactly the same for every single application that you run. Cluster operations, which focuses on just running the Kubernetes cluster and providing Kubernetes as a service. And then finally, your application operations people. And I think this is really what the whole DevOps idea was kind of going for in the first place, which is to say, let's have the people who understand the application be responsible for the operations. But I think where DevOps fell down, especially in early implementations, was that it also meant that that same person was also responsible for the hardware and for the kernel, and that's clearly a bad idea. So Kubernetes has come along and enabled this decoupling of operations. And then when you combine that with the cloud, what you see is that you can actually give away those operations to a cloud service. So in the case of using Azure VMs, you've actually given away hardware operations. Azure and Microsoft will take care of hardware operations for you. And obviously you still have to maintain OS, cluster, and application. But if you take Kubernetes and you actually use something like the Azure Kubernetes service, you can actually get rid of most of your operations and focus exclusively on the area that's important to you, which is your application and your application operations. And so Kubernetes, by decoupling application from cluster and cluster from operating system and operating system from hardware, has actually enabled companies to reduce their operations footprint, and especially in moving to the cloud, focus on the core applications that are the core business value for them, and leave behind a lot of the details that really are not necessary or even mission critical to their business. All right, so we're going to talk a little bit more about the Azure Kubernetes service itself and how Azure delivers managed Kubernetes at hyperscale. When we think about the Azure Kubernetes service, it's all about taking that open source project and delivering it to you in a way where all of the operations of Kubernetes itself are taken care of for you. So this management includes 24/7 on-call engineers, who, as well as automatic detection and repair of clusters if there's problems. It includes things like cluster auto-scaling, which means that really from a cluster operations perspective, you can trust Azure to deliver the Kubernetes API in a reliable way without any interference or any requirement that you and your team be involved in the operations of that cluster. But it's more than just the operations. It's actually things like security with up-to-date Kubernetes builds, integration with Azure Security Center, integration with tooling like Active Directory, which allows you to easily manage the users who have access to your cluster. Also focusing on things like scale, enabling you to build the large-scale clusters that you may need to do machine learning, to do batch processing, or even large-scale web serving. Your applications can fit in the Kubernetes that is provided by Azure without you having to worry about how to deliver that kind of scale. Similarly, with regions around the world, Azure delivers the most Kubernetes in any managed cloud. And finally, we really focus also on being enterprise ready, ensuring that no matter what the requirements are of your company and your enterprise, Kubernetes can rise to that and the Azure Kubernetes Service specifically can provide an enterprise-grade, enterprise-ready by default implementation of Kubernetes. So let's take a look a little bit deeper at what this means. We saw this picture earlier of the Kubernetes API server providing an abstraction on top of machines. Well, in the Azure Managed Service, the API server itself is delivered by Azure. You don't see or pay for any of the machines or compute associated with that API server. It's delivered as a service for you. But of course, many times those machines need to be running services that are available to the customer in their own network, in their corporate private network. And so the machines themselves, where your applications actually run, they live in your private network. They live in a space that you control and that you can link up with VPN or VPC or whatever the tooling is that you need in order to manage those computers inside the same network as the rest of your company. That's where those applications are running. And so that balance of us taking care of the API server, but the workload actually running in your space really means that we can deliver a good management experience, but also you can easily build applications that meet the requirements of your company. But from a customer perspective, this is the real experience, that you're happy experiencing the Kubernetes API without really worrying about the stuff that lies below, right? And that is a dramatic simplification versus having to run all of your own infrastructure from the cluster on down to the hardware. And so we really make it easy for you to build the applications that work, but with a managed service. I think the other piece of this is security, right? It's critical for many of these applications that security be delivered as the first priority. And we manage this by enabling you to run the Kubernetes itself inside of your private network. So even as we manage the Kubernetes API server, it can live inside your private network. So only people who can access that cluster are people who are within your corporate network, within your corporate firewalls. The Kubernetes cluster itself is never on the public internet. That provides a great deal of security. Similarly, if you want, you can provide firewall rules that say only these particular IP ranges can have access to the Kubernetes API server. So you can really lock down that cluster to only the authorized people inside of the authorized networks. At the same time, we also have deep integrations with products like Azure Security Center, which means that not only can you lock down the access to your Kubernetes cluster, but you can also set up active monitoring for threats, for images that are out of date, that have known vulnerabilities, for configurations of containers that are known to be insecure. You can have that kind of threat modeling available to you within the context of Azure and in a service that Azure provides. So that's a really nice addition to the managed service that we provide. Azure Security Center can provide even more security for the clusters and the applications that you deploy into those clusters. Similarly, we really focus on making sure that you have access to the latest and the greatest in Kubernetes, right? Because it's one thing to have a managed service, but if you can't upgrade, if you can't take advantage of the new features, if you can't get patches to the security vulnerabilities, that's going to be a real problem. And as a demonstration of this, we are currently the only public cloud with Kubernetes 1.17 available. And as a service provider, Azure gets embargoed CVEs before they're released into the world. So we can be sure on day 0 that an exploit is revealed, that your clusters are patched and ready to go. Similarly, we maintain our own builds of both Kubernetes and Moby, which is the open source Docker, so that we can deliver patches as needed on the day that things are released, right? So we have complete security from the source code all the way through to the application that's deployed into your environment. Similarly, when we think about enterprise readiness and ease of management, one of the most valuable things that we provide is Active Directory integration. That means you don't have to worry about certificates for authenticating to the Kubernetes cluster. You don't have to worry about how you revoke those certificates if an employee leaves or if there's a vulnerability. Instead, you can use the same Active Directory identities that you're using to manage access to things like docs or machines in order to manage access to a cluster. That means you can come along and take a single person, add them to a single group. They'll have access to all of the different resources that they need, from the design documents that describe how an application is built, all the way through to the login access to those containers running on their Azure Kubernetes cluster. And I'm going to give a demo here of the integration with Azure and Active Directory. This is a demonstration of Azure Active Directory integration with Kubernetes. So I have a Kubernetes cluster that has been created with Azure Active Directory integration, and I'm going to access that cluster for the very first time. Just doing something simple like getting the nodes in the cluster. And what you see here is it's actually prompting me to go to Microsoft.device login. We'll go there. And now it's asking me to sign into my account with the code that was printed here. So we'll do that. And of course, if I have two-factor authentication or any other sort of validation, I'm already signed in, so it's not going to prompt me for that. But if I wasn't signed into the web browser, two-factor authentication, conditional access checks, all of the sort of details of AAD login would apply. I'm going to select my account. And now I'm logged in, and if I go back to the client, you can see here, now I've gotten access. And of course, it'd be annoying to have to do that every single time. And so now if I do kube control get pods, that login has been remembered, and I can get access to I get access to my Kubernetes cluster without going through that prompt every single time. If we take a look at the actual role binding that does that, what you can see here is that I have authorized my user account. But of course, you can actually also use things like Active Directory groups and other ways of grouping users together to handle access control to the Kubernetes cluster. So hopefully that gives you an idea of how you can use the same management that you do for docs and for other machine logins to manage access. I think another really important part of Kubernetes is being able to scale and being able to have access to the right kind of machines for the right kind of workload, right? And so one of the other things that the Azure Kubernetes Service provides is this idea of a node pool. And that's because you may want to have a single unified Kubernetes cluster for ease of management, but the applications that you deploy to that cluster may have very different needs. You may have some applications that need access to a large amount of CPU. You may have applications that need access to GPU. You may have things that are low priority and you want to have cheaper prices. And we provide the ability to combine all of these different kinds of machine types together into a single Kubernetes cluster. So whether it's GPUs to do machine learning, nodes that you want on the edge because they're connected to the public internet, nodes that you want to be super cheap because you're only running, background batch jobs on them, all of those things can be managed and scaled within the context of a single cluster. It makes your task of building and deploying your application onto the right hardware much, much simpler than having to manage all of these different pools of compute separately, focus on deploying things differently to all of them. It's a really big ability to enhance the ways in which you manage your applications at scale. I think the other part of scaling is actually a regional presence around the world. Every large-scale application that is being developed is ultimately looking to become a worldwide application. And that's where Azure can help. Azure has more regions of managed Kubernetes than any other public cloud provider. And so if you need to be in a particular region, whether it's for reasons of latency, for compliance with local regulation, or simply because you need that global scale, Azure can deliver the same managed Kubernetes service experience, whether you're deploying an application to the United States, to China, to Europe, to Africa, Australia, or really anywhere in between. We have more regions and will have more regions of Kubernetes available to you than anyone else. And that's an important part, not just of scaling your cluster within a region, but actually being able to scale your application around the globe. I think another really important part of deploying applications beyond scale is thinking about how we deal with security and identity. Identity is a critical component of any security environment, and Azure has really focused on how do we deliver this for your applications. And to that end, we've created something called the Azure Active Directory Pod Identity. To give you an idea for the problem that we're trying to solve, when you look at a typical application in Kubernetes running, the identity that is given to the pod is the same for every single pod that happens to land on that machine. And even worse, the identity is actually also the same as the machine's identity. So this means it's very difficult to provide fine-grained, least privilege access control to your applications. Every single application that runs on a particular machine has to have access to the same set of resources, which means also that if a particular container gets exploited, the attacker has access to all of the possible resources that happen to be running on the machine. This is clearly not a great situation because you want to make sure that you have least privileges for every single application. To fix this, what we do is we introduce the idea of an identity per application. So every single pod that runs in the system has its own identity. And the machine has its own identity as well. And so that means you can say things like the back end has access to the database, while the front end pod doesn't, and the machine pod doesn't. This means that you've really locked down the abilities of your applications to the things that they need access to, and really reduces the footprint of exploit if an attacker happens to compromise a particular application. It's a critical component of delivering enterprise-grade applications on Kubernetes, and something that is a unique feature in the Azure Kubernetes service. I think in addition to identity, you also want to think about policy. Policy is a critical component of keeping an eye on what's going on inside of your Kubernetes cluster and making sure that the applications themselves that are deployed are both reliable and also secure. To give you an idea of the importance of policy, we look at how we control the access to a Kubernetes cluster. Well, the very first way that you're doing it is through something like role-based access control, or RBAC. That means that you can take those identities, either the pod's identity or a user identity from Active Directory, and you can say things like, this identity has the ability to create pods. This identity has the ability to access this particular secret. That's great for providing sort of a baseline of security to prevent malicious users from even getting access to the Kubernetes cluster. But how do you prevent good users from perhaps making mistakes and doing the wrong thing and creating an insecure environment? In particular, how do you answer questions like, where is the image that you just deployed from? Did you get a security review from our security team? And other questions like, where's your team's mailing list that might not be about security, but are about automation or being able to deliver at-scale solutions that can communicate with a particular person to tell them, for example, that their application is insecure, or that their application is a runaway wasting CPU, or opposite, their application appears to have never been deployed for the last 3 months, and maybe it should be deleted. All of that kind of metadata that you want to be able to enable large-scale automation of your application only will get added to the objects in your cluster if you use something like policy to enforce not just access to particular resources, but the shape of those resources. And so policy is a critical component in addition to access control and in addition to identity that enables you to describe not just whether a resource can be created, not just whether someone can create a pod, but also what the shape of that pod looks like. Let's take a look at a concrete example. So here, we've actually inserted a policy agent. In this case, it's the Open Policy Agent, which is an open source project that's available in the CNCF. We've inserted this policy agent in between the user and the API server. This policy agent has access to all of the requests that flow through from the user, and it can enforce rules to say, hey, you know what? We can't use that particular image, or you need to create at least 3 replicas of your application, or you need this metadata tag, right? And that really enables you to not just describe not just describe the resources that a person has access to, but also really manipulate and force people to obey the right rules for how they create those resources in the first place. But of course, if you're managing any number of Kubernetes clusters, if you're managing these clusters at scale, if you have lots of different Kubernetes clusters for your organization, keeping all this policy information in sync across all of those clusters can be pretty painful. And that's why we've worked with the Azure policy infrastructure to actually take policy and make it something that you can subscribe to in Azure. So that there's a single point of truth, a single source of truth for all of your policy information that applies to every single cluster that you create. And in fact, it can be applied to clusters that are even off Azure. So we can ensure that every single Kubernetes cluster that you ever create provides a compliant environment, and that the applications that are deployed there by your developers look and feel the same across every single instance of Kubernetes that ever exists in your organization. And that's a huge step forward in terms of delivering the sort of consistency reliability and security at scale that any large-scale enterprise needs out of their infrastructure. I think it's important also to note that this whole work, all of this work, was done as an open source project, right? And I think it really demonstrates our approach to open source and how we think about integrating open source into the Azure Kubernetes service. You know, it always starts for us with an unhappy customer. It starts for us with a customer who has a requirement and a need that isn't being fulfilled. And in particular, in the case of policy, it was customers who were saying, I need to be able to limit what my developers are doing within this Kubernetes cluster. I love Azure policy. How can you make it work for the Azure Kubernetes service? And we started an open source project in response to that customer need. That turned into this open source project called Gatekeeper within the confines of the Cloud Native Compute Foundation, or CNCF. And then we also took that project and turned it into a part of our Azure product. So it's not just to take and create a project that's source code out on GitHub. It's actually to take that source code and bring it back into our product as a supported feature, as something that you can, wake my engineers up for if it's not working correctly, as a thing that you can absolutely rely on as part of the product, not just an open source project that you happen to download from GitHub and run. It's an incredibly important trajectory from a customer need to an open source project to an Azure product to a happy customer on the other side. And we repeat this pattern over and over again in all of the sort of open source work that we do in the Kubernetes community. And that leads us to the interactions between Azure and the Kubernetes community, how we think about building innovation and contributing back to not just Kubernetes, but actually to other open source projects that run on top of Kubernetes. I want to start out by talking about why we contribute in the first place. We could just take this open source project, we could manage it for you, we could deploy it, make a service out of it, and never contribute a single line of code back. And in fact, there are clouds that do precisely that. But from my perspective, first of all, that's not being a good community citizen. That's not being respectful of the time and energy and devotion that people have poured into these communities. But more importantly, it's also not a really good way to deliver a service, to deliver a product. If you're not involved in the community, if you don't have people who deeply understand how the project is built, where the bugs are, where the bugs need to be fixed, you don't have the ability to deliver a product based on an open source project that a customer will want to use, right? You have to be deeply ingrained in the community in order to have enough understanding to be able to deliver it reliably, to have the ability to land code, to either to add features that customers need or to fix bugs that they are facing. And you're simply not going to have the connections into that community to find out when there are things like security problems or the best practices that a customer needs to deploy their own application on top of Kubernetes. And so for all of these reasons, for altruistic sense that we have a responsibility to help these communities move forward, all the way through to the fact that I know that it makes it possible for me to deliver a better managed Kubernetes experience. Those are all of the reasons why we contribute back to the Kubernetes community. One of the places we really like to contribute is in innovation, right? And so a couple examples of how Azure is bringing innovation to the Kubernetes community include things like the virtual kubelet, which is focused on how do you build nodeless Kubernetes? How do you build a Kubernetes where there are no virtual machines, where there's only serverless containers floating around? That's been an ongoing project that's integrated with the Azure Container Instances service within Azure, also integrated with Fargate in Amazon, as well as work with Alibaba and others to bring this, to push forward on this idea of nodeless Kubernetes. And that's still very much a work in progress. It's a CNCF project that continues to find community life and help with the innovation, help drive innovation into Kubernetes. A more recent example, one of the engineers on my team, Cal, was up on the keynote stage at KubeCon San Diego, talking about how he had worked with Tim Hawken and others from the Kubernetes network community to deliver IPv4 plus IPv6 dual stack support into Kubernetes. It was a giant, complicated change that Cal drove into the project, touched something like 5,000 different lines of code, almost all of the SIGs. It required an incredible amount of community engagement and consensus building, and he did it successfully and delivered that feature for our telco customers, as well as honestly any Kubernetes user anywhere who needs to run containers with both IPv4 and IPv6 addresses. It's a great example of how we contribute innovation to not just benefit our Azure customers, but truly to benefit Kubernetes customers across the world. We also think a lot about building tools on top of Kubernetes. How do we make Kubernetes easier for people to use? We have tools like Helm, which deploys something like 80% of the workload that's deployed to Kubernetes is deployed using Helm. It's a fantastic tool for packaging and managing applications in a Kubernetes cluster. And it's obviously an open source project in the CNCF, but it is largely supported by engineers from Microsoft, largely supported by engineers from my team, who work in conjunction with the rest of the Helm community to take that project and move it forward. They recently had a really successful Helm 3 launch, and it's really awesome to see just how many customers of ours on Azure Kubernetes Service are using Helm, but honestly to see the people around the world who are finding success with Helm, no matter where they're running Kubernetes. More recently, we've been focused on the service mesh and how can we bring innovation to that space. Focused on the service mesh interface, which is a generic interface so that multiple service meshes can all present the same interface, and so that tool vendors can build tools for service meshes that don't have to be tightly bound to the details of any particular service mesh. A little closer to home, we've also done a lot of work in VS Code to make Kubernetes a really awesome experience within VS Code. Because for many developers, interacting with a cluster inside of their editor, inside of their development environment is far more natural and far easier than dropping down to a command line and having to learn a bunch of esoteric commands. So I wanted to give you a demo of exactly what that looks like for our VS Code support.
This is a demo of the Kubernetes extension for VS Code. I'm here in VS Code, and you can see I have the Kubernetes extension installed over here from the marketplace. The Kubernetes extension adds a new view which shows me all of my clusters, and I can actually dive into those clusters and see, for example, the nodes and get information about those nodes simply by right-clicking on them. It gives me the information about the node. I can see all of the pods that are here, and at a glance from the little green dots I can see that they're all running correctly. If I want, I can actually go and get a terminal into that container. And that gives me an interactive terminal running inside the container itself. So this is the container's file system, not my computer's file system. I can even go over and right-click on a pod and set up port forwarding so that I can securely access services that are running in my pod. So I go over here and go to localhost 80. And now I'm actually accessing that security camera service that is running within my Kubernetes cluster. This is all happening through a secure tunnel that's been established between my local machine and the Kubernetes cluster. I can even actually go and view the data for the pod itself. So we see here the YAML that's associated with the container. And Kubernetes YAML can actually be kind of complicated. So I can actually say, hey, I want there to be, go into explain mode, where if I activate explain mode, I can actually go and hover over a particular object. And I see the description here of the object, of what that object is. And if I go and edit, if I go over and actually edit my pod config, where is the version? Say, for example, change my container version to v3, save that, and actually I can say I want to apply that. It's actually going to show me a diff here. So what you're going to see here, it's highlighting the diff, and so now I have confidence that if I apply this configuration, this is the only change that's going to happen. So hopefully that gives you a demonstration of how integrating Kubernetes with your development environment can make it easier and more intuitive for you to explore, learn, and manage Kubernetes in VS Code.
Now, I also want to talk about how we think about cloud-native leadership, right? Because it's not just about contributing innovation. It's not just about building tools. It's actually also about helping these communities move forward. right? And we have a number of people who have deep technical experience with Kubernetes and with cloud native technologies. And we feel a responsibility to use that knowledge and use that insight to help these communities at a technical level and at a leadership level move forward. We have people on the technical oversight committee for the CNCF. We have people on the governing board for both the CNCF and the Linux Foundation. We have people who were amongst the original founders and designers of the Kubernetes governance, right? So the people who actually designed and delivered the ideas of how Kubernetes is going to be governed and will be governed going forward. So I think it shows that we not just contributing code, not just contributing innovation, but contributing leadership to these communities, helping these communities move forward. And speaking of helping these communities move forward, it's critically important that we also do community service. We also do the work that actually literally day to day helps these communities operate. This includes things like, helping with the Kubernetes release, being release lead for the Kubernetes project. It's a truly thankless task. It's a bunch of hard work, but without it, we wouldn't be able to release software. Kubernetes wouldn't have new releases if it weren't for the people standing up to become release leads. We've had people on my teams lead Kubernetes SIGs, be involved with the CNCF SIGs, and then also our great field folks all around the world focusing on building out and delivering Kubernetes and cloud native meetups so that we can do that sort of grassroots discussions with local people who are working on solving these problems in their own environment. And it's a really great resource, not just for connecting with those people, but actually for bringing features back to the Azure Kubernetes service so that we understand what do we need to build in order to help make these people productive and happy. And then finally, thinking about teaching and education, right? One of the things I really love to do is actually do talks like this and help people learn more about Kubernetes. Done a whole bunch of work with Microsoft to deliver talks on YouTube, as well as with a bunch of our great field engineers to deliver a best practices book. And so if you're looking out there for cloud native education, Microsoft and Azure has the expertise to help deliver those materials in a variety of formats to make sure that you, as you're going through your digital transformation, you have access to the right kinds of education, the right kinds of materials to help upskill your workers as they make a transition maybe from some more legacy development up through cloud native development. Now I wanted to talk about the Azure Kubernetes service in China, right? So I think that speaking of going to the local and speaking of delivering tools that are important for people where they are, we really have focused the Azure Kubernetes service on delivering a service in China. And that's for a variety of different companies, from national companies within China itself to multinational companies like Starbucks, who are delivering products into China as well as the rest of the world. We know that the Azure Kubernetes service is enabling those people to drive success. So taking a look at a couple of those, here's some examples of the way in which the Azure Kubernetes service is growing in China, as well as a couple of our really great partners. Daimler is a great example of a multinational company, and an example of a local Chinese company that is finding extreme success as they've deployed and started using managed Kubernetes on Azure. And with that, I'm in conclusion, and I want to say thank you so much for listening. I hope it was enjoyable, and have a great day.
好，欢迎各位回到台北数位时代的现场，我是 James， 坐在我旁边的是 FunP Group 的 CTO Anderson 哦。那我想刚刚各位跟我们一起在线上看完 Brandon Barnes， 也就是 Kubernetes 的 Co-founder 共同创办人的直播，他自己来告诉我们 Kubernetes K8s 最新的影响，还有他提到了几个重点，包含他简介了整个 Kubernetes 的这个架构，然后接着是他介绍了在 Azure 上面 Kubernetes 相关的 Cloud Native， 也就是云端原生的服务哦。那第三件事情，他也跟我们分享了目前 Kubernetes 发展的状况，包含跟 Linux Foundation 去合作，做这个云端的相关的这些 Open Source 的这些社群。然后最后他还提到了 Kubernetes 目前在大中华区的发展状态。那我想在这整个部分里面，它其实除了提到 Kubernetes 有4个 pillar 的概念，包含了 pods 里面可以装容器，然后最小的硬体单位是一个 worker node， 一个工作节点，然后工作节点还可以分成 master 跟 non-master 的版本。 然后一个 master 可以跟很多个不一样的 node， 跟很多不一样的节点组成一个 cluster 这样子Kubernetes 的概念。另外，他也提到了透过这样虚拟化的工具，其实帮助了很多不同工作变得可能可以让很多的开发团队切成小团队去运作，讲了2个披萨的原则，而且也帮助我们去理解为什么要做 DevOps 的这相关的事项，包含透过应用程式层级、Cluster 层级、Kernel 也就是核心层级或者是硬体层级的这些营运哦。那我想 Azure 其实提供了很多样的这些管理服务，帮助我们可以把 Kubernetes 这样 Cloud Native 的这些服务原生的带到我们现在的很多云服务的开发的环境当中。所以我首先想要请教这个 Anderson 在这个开发上的经验哦，也就是说像 Kubernetes 这样子提供虚拟化管理的这些工具呢，实际上我们要把它落实到一个企业里面去做这个，或者是组织里面做这个开发团队运作的时候，有没有什么要特别注意的地方，或者是美感，可以帮我们分享一下
？OK， 好，我想从一个开发团队的组织的角度来看的话。事实上，如果我们回想一下，说我们自己在开发 APP， 然后真的放出去给我们 user 来使用的这个整个 life cycle 的角度来看的话，你会发现是说你的团队里面的人，第一件，如果你的 APP 要做得更大了，你其实一个比较大的挑战是你怎么分工。否则来讲的话，我们过去来讲可能会有，譬如说有那种天才工程师，一个人或者少数几个人去 build 一整套的一个系统，很多的大公司其实早期都是这样，是。可是你不可能永远维持在这个阶段，所以当你想要去做一个扩充的时候，其实对于组织或者是开发团队来讲，你其实比较大的挑战是，我怎么样用更多的人也可以做更多的事情。那这时候分工变成一件重要的事情。可是分工从哪里来？这个分工其实一个非常重要的一个点，其实就是在这里面提到一件事情，就是怎么做 decoupling。你怎么真的把工作给分开，让你平行的团队在运作的时候不会彼此互相打架，就是大家可以同时运作一段时间之后，然后大家再开始合起来。你如果简单的讲，在Computer Science 我们常常讲 divide and conquer 嘛，你总要先找一个方式，先把它分开，然后大家平行能够运作在一段时间之后再把它合起来。是。那 K8S 某种程度上来讲的话，它协助了这件事情的发生。不过拉回来说，我还是得要从一个团队营运角度来看待这件事情，就是说这件事情呢，虽然说工具它提供了一个这样子的一个机制，让这件事情的发生的一个成本或发生的一个容易度变得提高了，成本变低了。可是实际上这件事情如果要做得好，其实还是免不了人。简单讲，那个分工怎么分这件事情，其实是机器不会帮你决定的。是人在做这件事情，那这个其实是我比较需要 highlight 这件事情。那当然 K8S 的一个导入或 K8S 的一个发明，事实上是我们在做这件事情的一个演进，我觉得是一个很好的过程，尤其是在一个云端环境下。因为过去来讲，这个分工的后一阶，就是说我们开发到一个段落之后，我要上线嘛。那通常上线阶段的你需要的人的一个营运那一端的跟你需要的人力，其实是跟开发阶段有一些不一样。不一样。对，尤其是跟网络端跟硬体端的那些人。可是这件事情在上了云端之后，你会发现说，这些事情其实慢慢的，其实云端的环境帮你 take care 大部分。所以你的 challenge 变成说，你应该把你的 loader 应该是从这边移开，尽量往上走。往上的话，其实说怎么贴近营运，比如说营运上突然需要扩增容量的时候，你可以多快？是。那这件事情当然在 K8S 这种比较虚拟化的一个管理工具环境之下，你要做这件事情的难度降低了嘛？但是一样还是牵涉到这个 planning 这个规划，这个怎么做好 decoupling 跟规划，这个可能还是一个开发团队最大的 challenge。对。
我想，刚刚其实 Anderson 跟我们的分享讲到了这跟云端有关的这个部分。事实上，刚刚这个 Barnes 在这个影片里面跟我们分享的时候，他提到了非常多有关，譬如说怎么样真正 enable cloud native， 也就是原生的云端的 service。怎么样帮助很多的公司、企业或者是组织，他们提供服务可以全部的是云端原生的公司，然后怎么做云端原生的开发或调度资源，然后另外还 有一个重点，其实他提到整个开源社群哦。那我在这边其实觉得有一个非常值得讨论的问题，应该要 highlight 出来讨论了。因为 Barnes 其实是一个技术开发者，然后他从技术开发者的角色，然后一直到现在他成为微软的这个 Azure 的 CVP， 然后他来跟我们分享这个 Kubernetes， 而且是亲自介绍这相关的整个进展，甚至他其实在提到为什么要做开源的时候，他有讲到了很多精神，为什么要这样子 open source 这样去做。那我想跟Anderson 这边请教或讨论哦，当你看到一个这种技术开发者，他在跟我们深入浅出的分享这个技术工具的进展的时候，你怎么去看待整个虚拟化的这些管理的工具或技术，跟接下来的这个商业的趋势会有什么样的策略结合，或者是接下来的特色？
了解哦。那我想在这一场演讲后半段提到一个，他比较多的心力其实放在说到底怎么跟开源社群做一个合作嘛。那这个我相信，如果说在那个技术圈待得比较久的人，其实对 open source 的这个社群的感受跟理解都不陌生哦。那如果回到商业面的角度来讲，其实我觉得一个很重要的意义在于说，过去其实在技术圈，我们常常在做一些开发的决策之前，你可能会需要比较辛苦的点是说，你要决定你该用什么技术来做，
对，
甚至是决定该用什么平台。
是。
那慢慢你会发现说，上了 cloud 之后，甚至像 K8S 这种架构出来之后，你这样的 decision making 可能就会跟以前的状况比较不一样。你可能会需要可以考虑的东西说，你的选择变多了。
对。
以前往往比如说你选择了 Windows 平台，然后你选择了某种 programming language，你招募的团队，你所建立的这开发 team， 可能就要往这边走。是。可是现在来讲的话，如果说慢慢的在 cloud native 的环境慢慢越来越成熟的时候，如果类似像 K8S 这样的概念渐渐形成标准的时候，其实你会发现说，在布建一个开发团队的时候，你的人才的选择的来源的容易度会慢慢变得比较更成熟，
因为有社群，
所以这是一个良性的发展。那回到商业面的影响，其实我会更从另外一个观点来看待这件事情，就是说，微软自己讲，而且我们自己在产业观察也是这样。现在大家会谈一个 term 叫做所谓的 digital transformation。某种程度上来讲的话，这个概念上，如果说产业慢慢比较多的产业都在走这条路的时候，你会发现一件事情是说，整个产业的运行会依赖电脑或依赖一些计算的比重会越来越高。是。那还有一件事情就是说，这个比重越来越高的时候，又回到我们前一个题目在讲的一件事情，就是说，你的商业营运的韧性这件事情也会变得是一个挑战，因为你的营运越来越多需要靠所谓的电脑来协助你，但是电脑的你过去来讲，你的营运可能变化，你人来处理嘛，可是现在的状况可能会变成是说，当你的营运的环境产生改变，你需要做一些调整的时候，你不是只有人变，你的系统、你的应用程式、反正你的计算逻辑，你就要做一些调整。是，那这个时候你会发现说，你可能营运端的一个维运，你怎么让它变成说不中断这件事情，就会需要设计好。是。那过去来讲，我们可能是说，我们在设计开发 APP 的时候，这件事情是不是纳入我的 spec， 就决定了你开发这个 APP， 到时候如果要升级的时候，它会不会中断？是。常常可能在大部分企业内的应用环境，你觉得说这个还好嘛，我们就停一下就好了。没这。可是未来如果说在数位化的这个时代，你会发现一件事情是说，你现在开发的东西可能不仅仅是对企业内部，可能更多是对外部的时候，是。那你不能中断，那不能中断的时候，你就必须把这件事情 design in。那 K8S 其实某种程度上来讲，它这个平台已经考虑了这件事情。所以我认为这件事情，透过一个怎么讲 open source community 的普及，让人才变得比较更容易取得的时候，其实间接的，其实从商业角度来讲，间接帮助到一个企业，它真的需要用技术力去做所谓商业转型的时候，其实是一个相对好的一个助力。这大概是我简单的 comment。是。Anderson
其实最后提到了一个很大的重点，是我们在讲这个数位转型哦。事实上，使用云到数位转型的这个过程，我相信是现在很多人在这2-3年，不管是商业决策者或者是开发团队，都会面临到一个非常重要的需求跟价值。那可是，在使用云对企业或组织来说，其实有很多要考虑的点，包含譬如说，使用了云之后，可不可以搬得走啊？要搬不走，要花多少钱？花多少时间？花多少能力？还有，我随时如果要转换平台， 台有机会吗？或者是有没有更好可以转换平台的对象呢？我以后要做开发或维运的时候，我找不找得到相关的开发者，然后接手的团队是不是容易能够接手，容不容易培养？我想这很多方面其实包含了这些都是问题。所以为什么刚刚 Barnes 跟我们分享了这么多跟社群有关的发展，它其实最后背景在谈一件事，就是对于企业来说，选择这样虚拟化而且是开源的工具，对于很多企业长期伸展，或者是他们要做企业韧性的时候，都是重要的考量。那我想今天很感谢大家可以花一个早上跟我们一起在线上学习 Microsoft 365，还有 Kubernetes 相关的更新跟开发的技术哦。那这部分呢，也很感谢这个 Funby Group 的 CTO Anderson 可以跟我们一起分享这相关的对谈跟经验。那我想很多洞见都值得我们重新思考跟省思，不是只是技术上面的演进，还包含如何配合商业趋势上面的运作。无论你是技术人员，或者是你是主管，或甚至是你是企业主，都可以好好借着现在全世界好像是因为新冠肺炎按了一个暂停键的时间来省思一下，接下来应该要怎么样帮助你的企业去做发展跟布局的策略。那紧接着，我刚刚在一开始的时候其实有提到，我们这是接连2天，4月16号台北时间跟4月17号台北时间早上，会带来的这个直播的分享哦。所以紧接着我要提醒大家，在明天早上9点，也就是明天星期五，4月17号星期五早上9点，我们会准时带来包含微软的执行长Satya的技术愿景的演说，还有包含 Azure 的最新进展，讲这个世界云端的这个技术呢，有什么要注意或更新的地方，看看微软又在哪些云的上面有做布局跟投资哦。然后还有刚刚我们提到的生产力工具 Power Platform 的一些最新进展跟最新的工具的发展，还有最后是 GitHub 为我们带来的 Keynote 演说。那我想请大家持续继续锁定在数位时代的官网跟脸书粉丝团，随时在这个新冠肺炎的疫情当前，跟我们一起保持健康 Stay healthy， 然后也一起持续的学习。我们明天早上见，谢谢 Anderson， 谢谢各位，谢谢。